Hi guys, welcome back to my channel. Today we're going to cover one of the biggest surprises for anyone entering the machine learning is realizing how different the real world is from what we learn in the courses. In tutorials or in classrooms, you are handed a very clean CSV file, asked to train a model and judged by accuracy. In reality, this is much more messier. Data is incomplete, business priorities keep changing, and the hardest problem often have nothing to do with algorithms. They are about people, process, and communication. So here are few ideas that makes much more sense once you have worked on a real projects. First one is talk to the business before you touch the data. Data is only a byproduct of how a business operates. If you don't understand the business problem first, the data can easily mislead you. For example, imagine you are building a customer churn prediction model. You spend weeks creating a highly accurate model that identifies users who stop logging in. Later, a customer success manager casually mentions that a competitor launched a huge 50% discount campaign during the same period. Since your data never captured competitor promotions, your model completely missed the biggest reason for the customers who left. Your job is not to build only models, it is to help people make a better decisions. Machine learning is valuable only when it improves the decision making. Even the most accurate model is useless if nobody can act on its prediction. For example, you develop an advanced recommendation engine with an impressive accuracy, but the marketing team only sends one generic email campaign every month, regardless of recommendations. In reality, a simple model that separates active and inactive users would have achieved the same business outcome while saving months of development. Next, we have a simple model that everyone trusts is often better than a complex model nobody understands. Accuracy alone isn't enough. If stakeholders can't explain or trust the model's decision, they'll hesitate to use it. For example, a deep learning model is deployed to approve loan applications. Everything works well until an impact or important customer is rejected and questions the decision. The legal team asks why the applications was denied, but the model can't provide a clear explanation. Eventually, the company replaces it with a simpler, more interpretable decision, even if it's slightly less accurate. Next, documentation is an investment in your future self. The code you write today may seem obvious, but 6 months later, it probably won't. So, a production issue appears months after deployment. You often forget what you have written. So, you open a notebook named some class file and find a mysterious variable multiplied by 0.43. So, there's no comments explaining why you did that. You spend days trying to understand the decision that once made perfect sense but are now completely forgotten. So the documentation is very important. And next thing is deliver something small as early as possible. In real world systems, they have latency limits, API constraints, deployment challenges, and unexpected integration issues. It's better to discover this early. For example, you spend months of in building a sophisticated NLP model for routing customer support tickets. After deployment, you learn the support platform requires response within 200 milliseconds, while your model takes over a second. A simple keyword based solution deployed early would have exposed these limitations before months of work were invested. And this is a one more important point. Read the entire error message before searching online. Most debugging time is wasted because developers jump straight to the last line of the error instead of reading the full stack trace of the error. For example, your training script crashes with a tensor mismatch error. You spend hours changing the batch sizes, image dimensions, and pre-processing logic. Eventually, you notice the very first line of the error log, the dataset folder does not exist. The real problem had nothing to do with the tensors. So make sure that you read the entire log message before even searching that in the Google. Next, domain experts often know what the data does not. So some of the most valuable information isn't stored in the database. It lives in people's experience. For example, if you are predicting equipment failures in a factory using a sensor data, during a site visit, a supervisor casually mentions that one machine frequently malfunctions whenever it rains because moisture enters through the loading dock. You add local weather as a feature and the model's performance improves significantly. So it's very important to gain the domain experts. Next, we have the tool called Mastering the SQL. It will save you countless hours. Python libraries like Pandas and PySpark are powerful, but SQL remains the most important language for working with data. For example, if you're training trying to join several massive datasets in Python only to run out of memory. A senior engineer writes a short SQL query that performs the same join directly inside the data warehouse and finishes in seconds. Knowing where computations should happen is just as important as knowing how. So, knowing SQL is also very important in machine learning. In machine learning systems, accumulate technical depth faster than traditional software. Unlike software bugs, problems are often go unnoticed because the system continues running while performance slowly degrades. For example, a pricing model ignores a product below $5 because of hard-coded business rule. A year later, inflation and new product lines makes nearly half the catalog fall below the threshold. Nothing crashes, no alert fire, but the business quietly loses revenue every day because the model is making outdated assumptions. And finally, we have the important thing is communication. It is one of the most valuable skills in machine learning. In today, technical expertise gets project started, but communications keeps the team successful. For example, a CEO is excitedly asks the team to build an internal version of ChatGPT by the end of the week. A less experienced engineer tries to deliver the impossible and burns out. An experienced engineer responds differently. That's a great long term goal. By Friday, we can build a semantic search tool that instantly finds the most relevant documents. It solves the immediate need while giving us the strong foundations for future AI capabilities. Managing expectations is often just as important as writing a great code. The biggest lessons in this is machine learning is not just about model algorithms or accuracy scores. Success comes from understanding the business, collaborating with people, making a practical trade off, and building solutions that create real values. The best machine learning engineers are not necessarily the one who know the most complex algorithms. They are the ones who consistently solve the right problems. Thank you.